Welcome to the DIY Honda Garage channel. The DTC P1717 relates to the transmission range switch ATP, automatic transmission ranges switch RVS, reverse switch malfunctioning, either due to an open circuit or a short circuit. The transmission range switch plays a critical role in determining the vehicle's current transmission position, which informs the powertrain control module, PCM, about which gear is engaged, particularly when the car is placed in reverse. Essentially, the switch sends a signal to the PCM, indicating the shift lever's position, ensuring proper gear operation and preventing unintended acceleration or reverse gear engagement while the vehicle is moving forward. If this component is faulty, it could lead to unanticipated transmission behavior. The switch is typically located on or near the transmission housing, making it somewhat accessible but still tricky to reach depending on other components present nearby. By adjusting this DTC, you can ensure that the transmission operates safely and effectively. The transmission range switch is an essential component of the Honda CRV's automatic transmission system. Its primary function is to monitor the position of the gear shifter and provide this information to the PCM. This includes determining whether the vehicle is in park, reverse, neutral, or drive. If the AT, automatic transmission R switch, fails to send the correct signal, it can result in unexpected behaviors, such as the vehicle not knowing when to engage reverse or not recognizing that it's in a different gear altogether. The transmission range switch is typically located on the side of the transmission case, connected via a 10-pin connector. This setup allows the vehicle to communicate the precise gear selection back to the PCM, ensuring the entire transmission system operates within its designed parameters. A fault in this switch could prevent the vehicle from shifting properly, making it crucial for overall vehicular functionality. Diagnosing the P1717 error code reveals several potential causes, primarily stemming from electrical circuit issues rather than mechanical faults in the transmission. The electrical problems may originate from broken or worn wiring, which can either create an open circuit or cause a short circuit that prevents the switch from sending accurate signals. Another common cause could be a defective transmission range switch itself. If the switch is faulty, it will lead to incorrect reporting of the transmission state. Furthermore, if the switch is not installed correctly, or if the shift cable has not been properly adjusted, this could also result in erratic performance, causing the PCM to receive erroneous information about what gear the vehicle is currently in. Identifying these underlying problems is vital in addressing the DTC effectively. When experiencing a P1717 DTC, drivers may notice several symptoms that indicate potential issues in the transmission range switch. One of the most significant symptoms is that the transmission may fail to shift into the appropriate gear, particularly when engaging reverse. This can lead to serious safety concerns, as the vehicle may remain in a gear other than the selected option. Another symptom to watch for is erratic gear engagement. For instance, the vehicle may unexpectedly shift from reverse to neutral without a clear driver command. Furthermore, the check engine light usually illuminates on the dashboard, indicating that there's a DTC stored in the system. These symptoms not only affect the drivability of the vehicle, but can also indicate further complications if they are not addressed promptly. The first step in troubleshooting the P1717 DTC involves verifying the automatic transmission R switch signal. To begin, ensure the ignition switch is turned to the on position, which powers the necessary systems for testing. While in this state, use the Honda Diagnostic System, HDS, to check the parameters of the AT R switch with the shift lever positioned in reverse, R. The key here is to confirm that the current conditions match the specified threshold values. If they do, This indicates that the ATR switch signal is functioning correctly, leading you to proceed with the next troubleshooting step. However, if the conditions do not match, it suggests an issue either with the installation of the transmission range switch or potentially with the adjustment of the shift cable itself. Therefore, proper measurement and confirmation of values are crucial in diagnosing this issue accurately. In the second troubleshooting step, you'll check the status of the reverse switch, also known as the ATP RVS. Maintain the ignition in the on-to position, and again use the HDS to observe the parameters while the shift lever is still in the reverse R position. Just like before, you're looking to confirm that the current conditions match the expected threshold. A yes would indicate that there is no active fault with the reverse switch signal. However, an intermittent failure still means the system can operate normally at times, but you would want to move to the next step if the conditions do not match. Understanding the importance of this step is essential because the reverse switch directly informs the PCM whether or not the vehicle should engage in reverse operation. A check here ensures that your vehicle's operating conditions remain safe and reliable. Step 3 focuses on checking for an open wire condition in the ATP RVS line, which is essential for the proper functioning of the transmission range switch. Start by turning the ignition switch to the lock 0 position to ensure all systems are powered down. Once this is done, disconnect the 10-pin connector from the transmission range switch to isolate the circuit you wish to test. After disconnection, turn the ignition back on or press 2 to provide power to the circuit. Then measure the voltage between test points specified in the diagnostic protocol. Specifically, test point 1 corresponds to the ATP RVS line coming from the switch, while test point 2 should make contact with the body ground. Verify that you see battery voltage at this stage. If yes, it suggests that the wire is intact and free of opens. If no voltage is detected, an open circuit is present, necessitating repairs in the ATP RVS wire connecting the switch to the PCM. In the final troubleshooting step, you will check for continuity within the transmission range switch to ascertain its operational status. First, ensure that the ignition is turned to lock 0 while keeping the 10-pin connector disconnected. As you proceed, measure the continuity between test points 1 and 2, where test point 1 refers to the transmission range switch terminal number 5 and test point 2 to terminal number 6. A significant part of this check is verifying that continuity exists when the shift lever is positioned in reverse, R, and is absent in all other positions. If continuity falls within these parameters, this verifies that your transmission range switch is functioning appropriately, suggesting it may need a PCM update if issues persist. Conversely, a lack of continuity indicates that the switch itself could be faulty, leading you to replace it before re-evaluating the state of the system. Final steps entail performing a rigorous repair verification process to ensure all corrections have been adequately addressed. Start the process by reconnecting all previously disconnected connectors to ensure proper electrical contact throughout the system. Next, with the ignition in the on-to position, use the HDS to clear the DTC from the vehicle's memory. This step is crucial as it resets the code, allowing the system to re-evaluate the newly established conditions without prior faults lingering in the system. Start the vehicle with the shift lever in the park P position while ensuring the brake pedal is engaged. Following this, shift the lever through R, N, and back to R while monitoring the OBD status for P1717. If the HDS indicates passed, it signifies that the repairs are effective and that the troubleshooting is complete. If not, further checks on the wiring and switch are required. Preventive maintenance is vital for ensuring longevity and proper function within the transmission system, especially regarding the transmission range switch. It's advisable to routinely inspect electrical connections for any signs of corrosion, fraying, or other damage which could lead to intermittent operation. As wiring issues are common culprits for such DTCs, proactively address any wear or stress in the wiring harness goes a long way in avoiding future troubles. Furthermore, keeping the PCM software updated is an essential maintenance step, as enhancements and bug fixes can improve vehicle performance and avoid derived DTCs from software incompatibilities. Regular maintenance checks can prevent small issues from escalating into more significant concerns, thereby ensuring a reliable driving experience. In conclusion, addressing the DTC P1717 requires a careful focus on both electrical circuit integrity and the functionality of the transmission range switch. Proper diagnostics must identify whether the issue lies within the circuit, the switch, or possibly the connections between components. It is necessary to proceed systematically through the outlined troubleshooting steps to ascertain each part's condition. Moreover, implementing routine maintenance practices can mitigate many risks associated with this and similar DTCs, ultimately enhancing the vehicle's driving safety and reliability. The collaboration of these practices proves vital in fostering a dependable automotive experience while ensuring you're prepared for any potential issues. Being proactive now can lead to significant savings and trouble-free driving in the future. Please like and subscribe to the channel. See you next time.